Good morning, everybody. Today we will discuss division algorithm for polynomials. Before that, we should know lemma and algorithm. A lemma, it is a proven statement used for proving another statement. A lemma doesn't require further proof for it. Lemma is accepted as the statement is given. It doesn't require any proof of it. Now see here, we are coming on algorithm. Algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. It means that you can compare algorithm. Suppose that if we have to reach to the first floor, then for reaching to the first floor, we have to move through the stairs. And say number of stairs, there are n. It means those number of steps taken together, that forms an algorithm. As in the case of Euclid division lemma, we apply Euclid division lemma in order to find out HCF. And all the steps which we have done to find out HCF of given number by using Euclid division lemma, that all the steps when taken together, they form Euclid division algorithm. Algorithm, it means that all the steps, all the well-defined steps we are taking together. As all the steps we are taking to reach the first floor, we are taking it together, then it forms algorithm. Now after this, we are coming on division algorithm for polynomial. See here, we will try to understand it by the process as we used to do division from our childhood. Suppose that we have to divide this 19 by 3. See here, this 19 is divided by 3. Now 19, it is dividend. We call this 19 as dividend. And this 3 is divise. We will read table of 3 and 3 6s are 18. If we subtract this 18 from 19, we are getting 1. 1 we call as remainder. 1 is remainder, 6 is quotient, 19 is called as dividend and 3 is divisor. See here, 19 is dividend, 3 is divisor, 6 is quotient, 1 is remainder. And we used to do check for the division process. What we used to do is we multiply divisor and quotient. See here, divisor is 3. When 3 multiplied by 6, it gives us 18. And when we add remainder, remainder is 1 here. When we add remainder, 18 plus 1, it is equal to 19. If divisor into quotient plus remainder, it is equal to dividend. It means that our division process is correct. This is only division algorithm. This we have seen in Euclid division algorithm. Now the same thing we will apply for the polynomial. See here, it will be more clear to you from here. Suppose that here px is one polynomial which we have taken as dividend. This is px is divided by gx. Gx is our divisor. On dividing px by gx, we are getting quotient as qx and we are getting remainder as rx. See here, it will be more clear to you from here. Px is our dividend here. Then we have divided it by gx. Then we are getting here quotient qx and remainder as rx. Only in terms of polynomial it is. And all the polynomials are in the term of variable x. We all know the check process for the division is that divisor into quotient, and whatever is coming, we will add remainder to that, and it has to be equal to the dividend. This is only the check process for the division. Now just we will simply put the values in place of, see here, in place of divisor gx, then in place of quotient qx, in place of remainder rx. Gx into qx plus rx, and it will be equal to our dividend, that is px. This is simply called as division algorithm for polynomials. Always remember one thing, this remainder, it will be equal to 0. This polynomial for the remainder, it will be either equal to 0 or its degree will be always less than the degree of this divisor. As in the case of simple division, see here, in this case the remainder is 1. Either the remainder can be 0 or it will be always less than this divisor. In this case, remainder is 1. It can be 0 also, it can be 1 also, it can be 2 also. But it will never be equal to 3 in this case or more than 3. The same is the case in the case of division of the polynomial. See here, this remainder, it can be 0 or its degree will be always less than the degree of the divisor. It can never be equal or greater than the degree of the divisor. Simple. If we want to write it in the form of a statement, we can write it like this. If px and gx are any two polynomials, always remember that gx will never be equal to 0. As in the case of rational number, you all know that denominator can never be equal to 0. See here, suppose if here I am saying that you have to divide this 19 by 0. Are you able to? No. We cannot treat table of 0 in order to get 19. This is not possible, or we can say that simply this is non-defined. So gx can't be equal to 0. Now we have to find out polynomials qx and rx. Qx is our quotient polynomial in terms of variable x, and rx is polynomial for the remainder, in such a way that px is equal to gx into qx within bracket plus rx. It means px, it is divided by the polynomial gx, and then we are getting quotient qx, and we have added remainder to the product of the gx and qx. Always remember that this polynomial for the remainder, it can be 0. Its degree will be always less than degree of the divisor polynomial, that is gx. And simply this result is known as division algorithm for polynomials.